Oh, hello again. So this is structural analysis and design made fun and easy. This is now part 3. I think it's going to be part 3 of 5 now. Videos on BS structural steelwork design to BS 5950 brace short column. This is the most simple case, very simple, just to get started. Concentric axial load. And in this video, we're going to look at be looking at the effective height of a steel column. Which is pinned at the top basically, but I'll explain more in a second. This is part 3 of 5 in the series. Please like the video and subscribe to the channel. Please donate if you can to let me make more videos like this. So if you want to see what I've done in the other videos, that's part 1 and 2. They're available. Let's go down to, so this is part 3. And it says, it basically says on this part of it, here you can see, this is, right, hold on, this is, it's part D actually now. Sorry, we've done part C and we've done part C in video number 2. So let's just, if I can zoom in, you can see this bit better. Right. So for the text, just while I read out the text. So it says, determine the effective height of the column about both the XX and YY axis. So just in terms of the exam technique, there's 4 marks. Time allowed is then 4 times 1.8 equals 4 plus 8 times 4 over 10. 4 times 1.8 is 4 plus 8 times 4 over 10. That's right, 4 plus 3.2, so 7.3 minutes. So you got about 3.5 minutes for each part of this question. So say 3.5 minutes for XX and 3.5 minutes to work out YY. It's a little bit dark in it, but I can't put the flash on because it puts the too much reflection on the screen. So remember in the question it said the column is held in position. This is very important as well. The column is held in position about both axes at the top and bottom and partially restrained in direction about the YY axis. So I've referred to these diagrams in a moment at both the top and bottom. I should have put that the other way around, that would make more sense. Yeah, that's better. I'll just read it out again. The column is held in position about both axes at the top and the bottom. The column is held in position about both axes at the top and the bottom and partially restrained in direction about the YY axis at both the top and the bottom. Okay, so let's just, I'll just read out this text and I'll zoom out a bit for the diagram. So it says held in position about both axes. So as you can see, I've just drawn it out in 3D. I zoom the isometrics here. I'll zoom out again in a minute, let's just look at the plan section here on the right hand side. So basically, you've got it shows on the question XX is horizontal, YY is vertical. So basically, it says so what I was going to do, I'm just explaining the axes, but we're going to look at the XX axis bending about axial load about the XX axis first and then the YY axis second. So it says held in position about both axes. So this is my interpretation. This means that the overall supports cannot move because it's held in position. Held in position means it can't move. They cannot move laterally in the X or Y direction in this case. So it might be something like a brace frame, basically. It doesn't say exactly, but we know that it can't move. It's not supposed to be able to move laterally in the X or Y direction. Don't know about Z, but so basically also, so this is the first this is for both cases, but we're looking at XX first because it does mean that the column is free to rotate in direction, not fixed in rotation. So therefore, in the first case, let's look at the first case and I can explain a bit better. So therefore, in the first case, in the XX direction, we have these conditions at the top and the bottom. So in the first case, in the XX direction, we just got held in positions about top and bottom axis. So let's look at XX first. About XX is held in position about both the top and the bottom. Right. So zoom out a little bit. So this is on the here's the column. I just tried to draw 2D so you can see what I'm talking about. Isometric. This is XX axis. This is YY axis. Here's the top. There's the bottom. There's the column. This is a cross section. So in the question it said XX is horizontal about the middle. YY is the YY axis runs along the web. XX parallel to the flanges. So let's look at the little diagram. I've drawn out a little diagram to show what happens to when it says buckling about XX.